Lesson 13.2, Task 5. Derive the formula for the sum of a finite arithmetic series. The sum of a finite arithmetic series can be determined since the number of addends is finite. The sum of an infinite arithmetic series cannot be found because the number of addends is infinite and the sum will always continue increasing or decreasing. All right, vocabulary. An arithmetic series is the sum of the terms of an arithmetic sequence. So a series is just the sum of the sequence. All right, the formula for the sum of a finite arithmetic series can be derived by adding a general arithmetic series to itself, with one of the series written in reverse order, and then dividing both sides of the resulting equation by 2. All right. So let S of n be the sum of the first n terms of an arithmetic sequence. So S of n equals a sub 1, that's your first term, plus a sub 2, your second term, your third term, etc., all the way to a sub n. You know that each term in an arithmetic sequence is found by adding d, your common difference, to the previous term. Rewrite the sum above with each intermediate term expressed using a sub 1 and d. All right, so S of n equals a sub 1 plus a sub 1 plus d. So this would represent your second term. All you had to do was add your common difference to the first term to get your second term. And then you're going to add 2d, add your common difference twice to get to the third term, etc., etc. All right, so it says, how can the fact that a sub 3 equals a sub 2 plus d be used to explain that a sub 3 equals a sub 1 plus 2d. All right, so since a sub 3 equals a sub 2 plus d and a sub 2 equals a sub 1 plus d, then the expression for a sub 3 can be written as a sub 3 equals a sub 1 plus d again. And then if you look at that, that's going to be 2d. So you don't really need the parentheses here when you're adding. You only need parentheses when you're multiplying. If you were multiplying, it would be distributive property, but you're not multiplying, you're adding. So those parentheses can be dropped and you can add the d and the other d to get 2d here. All right, it says now write the expression for S of n with the terms in reverse order. All right, so remember we're supposed to write it out, then write it in reverse order, then add it together. All right, so S of n equals a sub n plus a sub n minus your d, your common difference, okay? And then this is a sub n minus 2d, etc., etc., till you get to the end. It says when the terms are in reverse order, why do the intermediate terms involve subtraction? All right, it's like going 5, 4, 3, 2, 1. If I go 1, 2, 3, 4, 5, I add 1 to get to the next term. But if I go 5, 4, 3, 2, 1, I subtract 1 to get to the next term. So up here we looked at it in this order. And then we're going to reverse it to go the opposite direction, and that's why we subtract. All right, so now it says add the two expressions for S of n together. So we have S of n equals a sub 1 plus a sub 1 plus d. And then we have a sub n equals a sub n plus a sub n minus d. So if we add these together, we get a sub 1 plus a of n, and then a sub 1 plus a of n, because your d's cancel, and that happens in each column. And S of n plus S of n equals 2 times S of n. All right, so we have 2 S of n equals a sub 1 plus a sub d n times. All right, so it says the right side of the sum of the two equations is a sub 1 and a sub n added n times. How do you know that the quantity a sub 1 plus a sub n appears n times. The expression for s of n is the sum of n terms. Each of these terms is paired with one of the n terms as a sum written in reverse order. Since each pairing yields the quantity, you can see up here a sub 1 plus a sub n, there are n quantities. Alright, so that yields 2s of n equals n, number of terms there, times a sub 1 plus a sub n. And now you're going to divide both sides by 2 because you want s of n to be by itself. So if I divide both sides by 2, that means our equation, s of n equals n times a sub 1 plus a sub n over 2. Alright, it also can be written in this form as well. Now, this is a common formula that you will see, and this was showing you how to derive or how this formula came about. You don't really need to know how to derive it as much as you need to know how to use it. So we will look at how to use this formula. That is something that you will see on the EOC. So if you have any questions on Task 5, please let me know. Lesson 13.2, Task 6. Calculate the sum of a finite arithmetic series. The formula for the sum of a finite arithmetic series is particularly useful when the number of terms is great. When the sum of an infinite arithmetic series cannot be found, the sum of a specific number of consecutive terms form an infinite arithmetic sequence can be found since those terms form a finite arithmetic series. Consider the arithmetic series consider the arithmetic sequence 2, 5, 8, 11, 14, and then ... means it's infinite. What is the sum of the first 25 terms? And again, even though we can't find the sum of an infinite series, we can find the sum of a specific number. So since it asks us to find the first 25 terms of this sequence, we can do that. So it says the arithmetic sequence formed by the first 25 terms of the sequence is a finite series. So its sum can be found using the formula s of n equals n times a sub 1 plus a sub n over 2. So this is the formula we found in the last task. So now we're going to use that formula. Alright, so it says what values are needed in using the formula. Select all that apply. Well, n is the number of terms. A sub 1 is your first term. And a sub n is the 25th term. So the value of the last term of the finite sequence. So since we're looking for 25 added together, this number in this case would be 25. So the value of the last term. We don't need the sum of the terms. That's kind of what we're looking for. And we don't need the ratio. All right, so it says the first term is 2. Okay, so that's given. We can see that right here, 2. We know n is 25. What we don't know is the 25th term. So we're going to have to find the 25th term. So the two values can be determined to find the 25th term. So remember, this is a formula we used in the previous task. So a sub n equals your first term plus n minus 1 times your common difference. Since we're looking for the 25th term, and we know that our common difference in this case is 3, we can plug these numbers in and solve. So we're going to do 25 minus 1 is 24, times 3 is 72, and then add 2 to get 74. So our 25th term is 74. So now we have our first term, our 25th term, and our common difference. So now we can use the new formula. All right, so it says, how is the order of operations used to evaluate the 25th term? All right, so first you find the difference in parentheses. Next, multiply the result by your common difference, which is 3. And then finally add your first term, which is 2, to the product. So order of operations still applies, always applies when working with math. All right, so now it says use the formula for the sum of the finite arithmetic series to determine the sum of the first 25 terms. So this is our formula, S of n equals n times a sub 1 plus a sub n over 2. So we're going to plug in 25 because we're looking for the first 25 terms, so that's our n. 2 is our first term, 74 is our 25th term, so we're going to add 2 and 74 and then divide by 2 and multiply by 25. Or multiplication and division, the order doesn't matter, but you do have to add 2 and 74 first. So they do 2 plus 74 is 76. Then they bring the 25 in and multiply to get 1900 over 2, and that means n is 950. So if you add the first 25 terms of that sequence, you would get 950. All right, so it says, how is the order of operation used to evaluate S of 25 or S sub 25? So the first thing they do is find the sum in the parentheses. And then they multiplied. And the last thing they did was divide. All right, so the sum of the first 25 of the sequence, 2, 5, 8, 11, and 14, is 950. All right, that's all for task 6. If you have any questions, let me know.